Okay, hi everyone. Welcome to this workshop on advice and guidance on how to build secure contracts. My name is Josselin Feist. I'm a principal security researcher at TruffleCon. If you don't know us, we are a security company. We do code review and we do research on security in particular to build like tool and use program analysis technique to find bugs. We are not a blockchain company. We do also security on traditional software, but we have several work on blockchain. So the goal of this workshop is to give you an introduction to program analysis. We're going to see different techniques, how they work, how you can manipulate them, and how you can use them. And we're going to use 3 different tools that are based on program analysis to find bugs in smart contracts. The main goal of this workshop is that at the end of this 3 hours, you should be able to use this tool in your daily job to help you to secure your contract. So, yeah, thanks, Mike. So before we go further, as I mentioned, this is going to be a lot of manipulation. So you can directly go ahead to this repo and clone it. Be sure to switch to the TruffleCon 2020 branch. As I mentioned, we're going to manipulate multiple tools. All the tools are in this Docker, so you can just pull the Docker and you will have everything. You can install all the tools that we're going to explore locally, but the Docker is just more convenient. All the links are in the chat. Okay, so the question that we're going to try to answer today is how you can test a contract to know if there is a bug inside. If I give you like this piece of code, it's a buy function in a contract. It's going to check if you are sending enough Ether, and it's going to increase. It's going to mint token to the balance. So if I give you this function, how do you know if there is a bug inside? Small spiders, there is a bug in this function, but we're going to see this later. The first approach that can come in mind are the use of a manual review or the use of unit test. Manual review is a process of going through the code and reviewing manually what it does, what it's supposed to do, and if there is any mismatch between what it does and what is expected to do. As you probably know, it's kind of difficult and time-consuming to manually review a code base, but for some type of bugs, it's the only way to find some really deep down and really like weird edge case in your code base. The second technique to know if there is a bug is to use unit test. You should use unit tests. You should have a good coverage. But even if you have like a 100% of coverage, and you track like all the instruction in your contract, you might still miss some bug. Most likely it's because when people are writing unit tests, you kind of try to test the good behavior of the program, and you might miss some misusage of the program that attacker can take advantage of. So another solution to find bug is to use program analysis technique. This technique can be more or less fully automated or can require the usage of an assistant or a human in the loop. In particular, we're going to cover 3 types of program analysis in this workshop. The first one with static analysis with Slither. The second one, which is fuzzing with Echidna, and the third one, which is symbolic execution with Manticore. So static analysis with Slither, basically the way it works is that it's going to analyze all the potential behavior of the program. It's going to create like an approximation of the program, and it's going to check for some issue. Slither comes with a command line which include a lot of inbuilt detectors, so you can just run Slither on a code base, and it's going to run detector and try to find security bugs. This is, if you have used Slither in the past, it's like the main way people are interacting with Slither. Today, we're going to see a more advanced users of Slither through its Python API. Slither comes with a version in Critic, which is a GitHub application, which is going to provide you with additional check. Slither, the open source version of Slither has something like 40 detector, I think, by now. And the version in Critic has 19-ish detector. It's the same program, it's just some detector are private and are only available through the GitHub application. The second tool that we're going to explore is Echidna. Echidna is a fuzzer. The way it works is that it's going to take your contract and generate random transaction to stress the contract and see if there is some hidden behavior in the contract. So fuzzing is a really successful technique in traditional software. You might have heard of AFL or libfuzzer, which are fuzzer for classic software that are used by security researchers to find bugs. It's really effective. The third technique that we are going to explore is symbolic execution with Manticore. So in comparison to fuzzing, which is just trying to generate random transaction to the contract, Manticore with symbolic execution is going to explore the program and represent a mathematical and have a mathematical representation of the program. With this mathematical representation, you are going to have strong guarantees of the properties that you are going to describe. This is more closer to like code verification. As you can expect, it's also more difficult to use and it's time consuming to write property and to check that. As a high level summary, static analysis with Slither it's really fast. If you use the command line, there's like nothing to do. You just need to run Slither on the code base and you have directly result. If you use the API in the way we're going to use it during this workshop, it's a bit more complex, but it's still not too complex. Echidna is going to take some time, but not too much. You can run Echidna for 10 or 20 minutes. The complexity is not too difficult, as we're going to see. And the third tool, Manticore, which is an easy piece of technology. It's more complex to use and it takes more time to run. At the end, you have a better precision. You can have like verification. You can even have a proof that there is no bug with respect to the properties that you are describing. Okay. So before looking on how to apply this tool and how to use them, let's have a small discussion on what kind of development workflow you should follow to take advantage of this tool. You can keep in mind 3 rules. The first one, follow coding best practices. This might seem straightforward, but sometimes people just forget about some best practices. And because of that, the code is difficult to read. And if the code is difficult to read, it's difficult to test. The second rule is you should spend some time to determine what you want to test. A code base, even a contract can be fairly large. You can have like multiple components. You need to spend some time looking at what you want to test and which component you want to test. Once you know what you want to test, you will be able to determine which tool you want to use and which one is best suited. The third rule is use the tool from the start. If you start using this tool at the end of the development, it might require like a lot of time to use them, to integrate them, to fix a bug, and might delay a deployment that you already have planned. So if we think about the first rule, which is following the coding best practices, if there is one thing you should always keep in mind is you should strive for simplicity. Write as much, as little as possible code. If something can be put off chain, keep it off chain. Write small function and modular component. If we consider the example, someone is asking a question. Okay. If we consider the example, the buy function that we saw at the beginning, this function does 2 things. It's going to check that the sender sent enough Ether, and it's going to mint the token. A way you can split this function for clarity is to divide it into two functions. One function that is going to mint, one function that is going to check if enough Ether were sent. Now you can pull the Docker in any place. It's saved globally. Okay. Yeah. If you split a function like this, it's going to be easier to test individual components, and it's going to allow you to reuse more easily like each functionality. Obviously, in this example, it's only a function which is like 5 lines long. So even if you keep it in the first version, it's okay. But just to give you an example that sometimes even something that seems straightforward can be split for clarity. The second thing that you should keep in mind, and you should spend some time before like testing and even before writing like the contract, is to determine what you want to test and what are like the different components in your contract. And usually, smart contracts have some kind of state machine in the. They can be represented as some state machine. In this situation, tools like Echidna or Manticore are well suited to test because they're going to explore different paths, and they're going to allow you to have an invariant to check if the state that can be reached have the correct property. If you want to test for the access control, and for example, you want to test that a variable can only be written by a function that has an only owner modifier, Slither is the best tool to check. If you want to test more complex access control, you should use Echidna or Manticore. If you want to test for arithmetic operation, it can be like integer overflow. It can be checking for the dust and the remainder of division. Manticore is the best tool just because it's going to give you guarantee. You can also use Echidna depending on what you want to test. If what you want to test is related to the inheritance of the contract. So you have a contract and you have like 5 or 6 different inheritance, and sometimes it can be difficult to know which function is going to end up in the most derived contract. Here, Slither is going to help you a lot. If you want to test the external interaction, Manticore and Echidna are better suited than Slither. If you want to test the performance, Slither is the best tool to check. And so on and so on. So the idea is just to determine what component you want to test and to think about how you can test them and which tool is going to be the best. So the last rule is that you should use this tool from the beginning. Typically, Slither or Critic, or Slither from the command line or Critic, you can just add them to your CI from the first line you write. It's going to detect vulnerability without any like configuration. So yeah, it's just going to give you like directly security feedback. Once you have some property or some invariant in your code that you can determine, you should start using Echidna to write property or Slither, depending on what you are going to try to test. Then once you have some critical piece of code that you want a high level of confidence, you can use Manticore. Because Manticore is more difficult and it takes more time to run, it should only be used as a focused tool in to test and to verify some specific piece of code. So start with Slither. Once you have some property, write the property with Echidna. Once you have identified some critical piece of code you want to verify, use Manticore. So before I start to dig into the tool and to start with Slither, is there any question I need to answer on this chat? No. Yeah, if you have any question regarding Docker or regarding the tool, let me know. Okay, let's start with Slither. So Slither is a static analyzer. Static analysis exists in different forms, from pattern matching, for example, a linter does static analysis, to formal verification with, for example, abstract interpretation. It's a really large topic. The static analyzers that you are probably using every week, if it's not every day, it's your compiler. It's going to analyze your contract to compile from the, Solidity to the bytecode. Static analysis usually rely on different code representation. The most common one is a control flow graph, where you just represent the source code in a graph. Yeah, I already went quickly through Slither. So it's a static analysis framework for Solidity. It has vulnerability detector, optimization detection, and so the kind of long-term vision for Slither is to be LLVM or Clang for smart contract. The command line version contains R140 public detector, from critical issue like reentrancy to optimization like a variable that could be constant. Private detector contains more complex pattern. So just to give you a small demo from the command line. Is this big enough? So here you have a contract. It's a pretty straightforward contract. You run Slither on the contract, and it's going to give you directly a warning. It's because in this contract you have a destination, an address for which you are sending Ether, but you are never assigning this variable. So as a result, you are just transferring to the address 0. Sorry. But today we are going to focus on a more advanced usage of Slither through its Python API. So because Slither kind of works like a compiler, it has a lot of information about the contract. You can iterate over all the contract, over all the variable, over like the link between the variable. It has a lot of inbuilt analysis, which gives it some semantic information. We're not going to explore all the possibilities of the steps that you can do with Slither, but we are going to have at least some basic understanding on how we can use its API. So how it works. So the API is in Python. The first thing is to import Slither, and then you start a Slither object where you give as an argument the contract or the code base you want to analyze. Here it's a solidified. It could be a Truffle project or any framework you're manipulating. Then from this object, you can iterate over all the contract. For each contract, you can, for example, print the name and print the name of the contract from which it's inheriting. And so on. From each contract, you can iterate it over the function, or you can print the name of the function, the visibility, the contract, the modifier, and so on. So the hands-on will start. So if you go on building, let me increase the size. On building secure contract, too much. On building secure contract on the TruffleCon 2020 branch, on Slither, the first part. So you can either use a Docker or install Slither locally. I would recommend to just use a Docker for now because all the tools that we're going to use are in the Docker. The way Docker works is that once you pull the Docker, you can run this command, and this is going to share the current directory where you are running the command inside the Docker, which means you can clone this repo, share the directory from your host to the Docker, and go through all the manipulation within the Docker. Inside the Docker, there is a tool that is called Solstice Select, which allows you to switch between different Solstice versions. So here you will just find what I already explained. And at the end, you have the basic information about the API and the scripts I just showed. once you write this, you can start with the first exercise. So the goal of this exercise is going to take this contract, which is composed of two contracts. Actually, there is one contract coin and there is my coin. The goal is going to be to simulate a situation where you are a writer of a contract and you know that this function should never be overridden by derived contract. You are writing a library, you're writing a piece of code that is going to be shared by your colleague, and you want to ensure that this is not going to be overridden because it could change the behavior of the code. Unfortunately, some colleague write another version of the contract and did overwrite this. So the goal of this exercise is going to use Slither to follow this algorithm to check if you can find out with Slither that this contract does not does override the main function. There is some here. Okay, and if you have any question, feel free to ask me on the session chat or directly on the direct message. And now it's up to you.
Quick question, Josselin. If someone wants to ask a question, do you want me to if they want to like come on audio and video, do you want me to let them do that as well?
Yeah, sure.
Okay. So if you have any questions, feel free to ask in the chat on the right, or you can also try clicking share audio and video if you want to ask that way, and I will approve you through the moderation panel.
Let's take 15 minutes for this exercise. So by coverage report, what do you mean exactly? So maybe as a bit more background, the way it's going to work is that it's going to compile the contract and it's going to take all the information as a compiler will do from the contract. So it's not going, for example, to run the tests or stuff like that. So you won't have like test coverage with Slither. Does that answer your question? So for the people who just joined, you can clone this repository. So it's critic. Let me copy it again. And the first exercise. And here you have the introduction to Slither, just one directory above. And if you want the example I just show, it's here. So in example, print basic information. So once you run this, you are going to share your local directory in Docker. You can explore this and just go through the path to be in Slither. It's here. In this, in the home TruffleCon. So basically, it should looks like /home/TruffleCon /building secure contract /program analysis /Slither. Does that work for you? Can you copy and paste the error, maybe in direct message? One thing you might have to do is to run solstice select to change the default solstice version, because the Docker might use solstice 7 by now. So if you have never heard about solstice select, I would recommend to check it out. It's a set of scripts that allows you to quickly switch between solstice version. As you probably know, it's kind of difficult if you want to switch between solstice 5, 6, 7, or even like 7.1, 7.3, or whatever. So solstice select is going to appear a lot. You can just, once it's installed, you can just switch like this. It's very convenient. So for Windows, the Docker should work. I think it's the same command. Let me double check. So one thing you have to do in Windows is to clone the repository. If you don't have a way to do git clone, you can just download the zip here to do the same. Just be sure to use TruffleCon 2020, the TruffleCon 2020 branch. Go here and download the zip. Okay. And then you just need to install Docker and it should work. If not, let me know. So for Platy, for this particular exercise, there is no a similar detector, just because it doesn't make sense as a like guideline to check for function override. There is a printer to do this, but there is not like a detector that is going to report it. So Benjamin, are you running inside the Docker? Like, can you do Slither, just one Slither? Because you need to pull and to do this one. So I'm creating polls for the session just to get a sense if it's working for you. So it's in polls session. Want to know if you can run the print basic information so that it will indicate that the Docker works and everything works for you. And the second one to know if you have finished the first exercise. Perfect. Yeah, all the manipulation are going to be with Docker. So the first exercise, it's a bit more difficult to get the Docker running, but once it's run, it should be easier for everything else. Um, yeah, so I'm going to try to find more about this. Perfect. Oops. Does anyone else has an issue with Docker or is not able to run Slither or any of the steps to do the exercise? So no, there is no clean way if you are using the API like this. Just because like this is a custom, it's a custom script, so there is no like there is nothing more. However, Slither comes with detector, and if you want to integrate, for example, a detector that you wrote, you can just go over here and you have like the word documentation of how to add a detector. It's a bit more complex because there is a syntax and there is like some additional information to provide. But yeah, if you follow like this, you can basically take your script and create a detector, and it's going to be within the platform instead of being an ad hoc script. Does that make sense? So if you run with this, /home/TruffleCon should be inside the Docker. Let me do. So this command basically means that you are taking the current directory and you are mounting the current directory from the host to the Docker, to this directory. This might not work for Windows, so you might have to write the path in the Windows convention. I'm not sure. Let me find out. Oh, good catch, Patty. So does anyone else has issue with Docker or how to run a Slither? Okay, yeah. Yeah, it depends on the command you are going to run. If you copy and paste the command from here, yeah, you should be careful on what is here. If it's home Truffle or home training. Okay, I guess we can see the result for this exercise. So, as I mentioned, the goal here was to follow this algorithm, where first you get the current contract, then you iterate over the contract, and you're going to check if there is a way that this function is overridden by some other contract. So I just solution. It's here. So the way it works is that first you just compile the project with, and you open the project with the creation of the Slither object. You take the current contract by using this function. Then you iterate over all the other contracts of the project. If this contract is within the inheritance, you take the function mint and you check if it's coming from the same contract. If it's not, it means that someone wrote a function that overrides this function. Does that make sense? Is there any question regarding this exercise? So there are many ways you could do the same. This is just one way to go through the algorithm, but yeah, you can create some other way to do like the same and to check the same idea. Okay. Let's try the second exercise. So it's in exercise 2, as you can imagine. So here you are in a situation when you want to be sure that your contract is going to follow a strict access control. And you want, as a developer, you know, and you want that only a couple of functions should not be protected with only honor. So you can either do this manually and always go through like the different public function and check, okay, does it use only honor or not? Or you can just use Slither to do it automatically. And it's what we're going to do. So we are going to create a whitelist of signature of functions that don't need only honor. So for example, here you have a balance of. You can assume that balance of doesn't need only honor. And you're going to iterate over all the function. If the function is in the whitelist, it's okay, you don't need to check. If the function is not in the whitelist and it's public or external, you can check if only honor is in the modifier. If it's not, you found a bug. So you found a function that should be protected but is not. So it's 30. So yeah, let's take 15 minutes for this exercise. If you also could answer the poll, the session poll, just to give me some feedback on how many of you managed to run everything through Docker and to go through the first exercise, it would be helpful for me. So as you see, typically, if you are like writing a library or writing a code base that is going to be shared with other developer, writing this kind of specific tech can be really useful and can prevent some catastrophic bugs from being introduced. If you have any question regarding the first exercise, just let me know. I can go back on it. So something that is probably also worth to check out for you is all the features that are already within Slither. So as I mentioned, you can just run in on a code base and it's going to run the detector. But in addition, it has many features. For example, it has so-called printer, which are some kind of representation of the code base, either in the form of a text or in the form of a graph and stuff like that. Typically, when I do like a code review, the first printer that I run is inheritance graph. It's going to take your entire code base and give you like the different contract in the form of a graph which represents the inheritance. It's really convenient if you want to like review a code base which has like 10 or 15 different contracts that have different level of inheritance. Contract summary and function summary can also give you like some idea of what is public, what is private, and stuff like that. Slither comes also with many tools. Typically, Slither check upgradability. It contains specific detector if you are using the delegate called proxy pattern for upgradability. I think it have like 17-ish, yeah, 17 detector. So if you have like two versions of the contract, which one is an upgrade, you can check with Slither if all the variables are in the correct order, if you didn't change something to constant and stuff like that. As you probably know, delegate call is kind of the delegate call proxy pattern is a tough one to use, so it's probably good to keep an eye on how to check. If you want to interact with the token, you can use Slither check ERC to see what type of ERC is supported. If you need to flatten a code base, you can use Slither flat and so on. So let's have 5 more minutes for this exercise. Yeah, I agree, Patty. So if you use within Slither, the logging is a bit better, but yeah, if you use Slither outside of the command line in some external script, yeah, the logging could be better. Especially it's a common mistake. So we have a partial support for Yule. It's supported, but you're not going to have the same level of information. Yeah, so the way Slither works, that it's going to convert solidity to an intermediate representation. If you use Yule, we do also the conversion from Yule to our intermediate representation, but not everything is supported at the moment. What version of? Oh yeah, okay. Yeah, it's actually a Yule issue that is going to be solved in the upcoming release that is going to be Monday or Tuesday. We recently added the support for Yule, and as a result, we had a couple of issues because of Yule. But yeah, this issue is known and it's already fixed in the master branch of Slither. We are trying to do our best to keep up with all the new feature from Solidity. If anyone has a solution for this exercise and wants to share it, we might be able to share the screen. So just let me know if anyone wants to share its solution. Otherwise, I will share mine in a couple of minutes. Thanks, Mike. Okay, let's see. Solution. So it's in exercise 2 solution. I just uploaded the file. So it's mostly similar to the previous script. You create the Slither object, you create a whitelist with balance off. You iterate over all the function of the code base. If the function name is in the whitelist, you continue. If it's a constructor, you continue. Otherwise, if the visibility is public, I should probably zoom a bit, sorry, is public or external, and only owner is not in the modifier, then you found a bug. You found a function that is not inside the whitelist, that is unprotected. So typically, the kind of scripts are not generic; they are specific to a specific need in the code base. Here, it will be that someone wants to have a strict access control and only whitelist the functions that can be called, the public function that can be called, without being the owner. Obviously, you can create more complex schema and have anything that match your code base. Okay. So, yeah, that's the solution. What you discuss. So all the solutions are in GitHub now. We just have to pull the latest version. So, as I mentioned, you can just use Slither from the command line, and it's going to automatically detect the most common bug with the inbuilt detector. But you can also use its API if you have more complex need and specific property within the code base that you want to test. As I mentioned, you might want also to try Critic, which contain more detector and yeah, which has a lot of nice feature. All the tools that we're going to use today are open source. So Slither is open source, Echidna is open source, and Montico is open source. And only half of the detector from Slither are private in Critic. Okay, let's switch to fuzzing with Echidna. So the main idea behind fuzzing is that you take your contract and you generate random transaction. You kind of want to stress the contract to kind of trigger unexpected behavior. Echidna has a specific type of fuzzer, which is called property-based fuzzing. So in traditional software, if you write something in C or C++, you're going to have like memory corruption, for example. So a fuzzer in traditional software is going to look for memory corruption. In a smart contract, you don't have this notion of memory corruption, or at least you should not have. But what you have is more like bug related to the logic of the contract. So this property-based fuzzing is well adapted. But it is basically that you're going to define a property and invariant that should always hold in your code base, and Echidna is going to try to break this invariant. So the property I've written in Solidity. What you provide to Echidna is a smart contract, the property you want to test. Echidna is going to stress your contract by generating random transaction. If it sees a function which is called transfer, it's going to call transfer 1, transfer 10, transfer 100, and so on. At the end, it's going to give you either a set of transactions that work the property if I found something, it's going to tell you that it did not find any issue in the code base. Well, let's consider this small example. So it's just kind of a token with an airdrop. Anyone can call airdrop and consume as a token. If you only consider these two functions, you might have other functions in the code base, but if this is kind of like the specification of what the airdrop is supposed to do, give 1021 and anyone can just consume the token. One of the invariants that you can have here is that the balance of the user should be always below or equal to 1000. Because you're going to receive 1000 and it's going to only decrease, and consume check that the balance is positive such that you don't have an integer underflow. So you can write a property in Solidity which just say the balance of the user should be below or equal to 1000. Property and Echidna are public functions that return a Boolean. If the Boolean returns true, everything is fine. If the Boolean returns false, it means that you break the invariant. Usually the way we use Echidna is that we're going to take the contract, we are going to inherit from it, and we're going to write the property in the derived contract, just for convenience. You run Echidna on this code, and you say, oh, I found a way to break this invariant, and later on you realize that there's this backdoor in the code base. This is an obvious, it's a straightforward example just to show how it works. So, in the same way that we did Slither, close everything here. We have program analysis / Echidna. So this is a brief introduction of what I already explained. So you can use the same Docker for Echidna. As Valti mentioned, here there is a typo, it's home training. So it should be home TruffleCon, depending on how you are going to run it. Check either home training or home TruffleCon. You might want to first go through the how to test a property, which describe everything I just explained. So you have this contract with a backdoor. You're going to explain how to write a property. So a property doesn't have argument. It returns a Boolean, and the name should start with Echidna. As I mentioned, we usually use inheritance. So you have this token you want to test, you create a test token, and you write your property here. Yep, and then you just run Echidna on the file or on the code base. It also supports Truffle and any platform you might use. And the first exercise is here. So here we have this contract, which is a token. And we are going to deploy the contract in a way that the initial, like the deployer is going to have 10,000 token. If you look at the contract, there's only like a transfer function and some pause function. And it's going to, because you deploy with 10,000 token and there is no minting function, the invariant that you can have is that no one should have more than 10,000, right? So the goal is going to create this property and to check it with Echidna. Here you have a skeleton for this. So you inherit test token from token. This is a default address of Echidna. You initiate in the constructor to say this address has 10,000, and you need to write a property that is going to check that no one has more than 10,000. Again, it's in program analysis Echidna exercise 1. Do you have any question? So it might be worth to just go through the example here before going through the exercise, just to be sure everything works. I've created a poll for Echidna in the poll session just to know if you managed to run Echidna on the example. And let me know if you have any question. I think we can take 20 minutes to go through the how to test a property and the first exercise. So because the property I've written in Solidity, I think Echidna has like a good ratio of level of effort versus result that it can give you. So I would highly recommend to try Echidna in your code base and to try to write some even simple property just to see how it works. I'm going to take a 2 minutes break. Once you manage to go through the how to test a property and you were able to replicate everything and run Echidna as a Docker, it would be great if you could just go through the poll session and just vote yes so that I know how many people managed to progress on this. Oh, no, there is a gas. No, you don't need to go over like the other file. I should have deleted them. So for information, the building secure contract master branch has way more exercise, and it contains also other guidelines and best practices. But yeah, during these 3 hours, we cannot do everything. So I selected a couple of exercises from this. That's why some of the files should have been deleted, but are not. Typically, the gas one. Just for information, typically with Echidna, you can detect functions that has a high gas cost. So what it's going to do is that it's going to take your code base, generate random transaction, and give you like a report on the gas consumption. This is really useful to know if some of the function can consume way more gas than it's expected. But yeah, it's a bit more advanced. Okay, I will be back in 2 minutes. Don't hesitate if you have any question. So for multi-contract system, it depends. One of the limitations is that you have to deploy a contract. So if you can deploy everything within the constructor, Echidna is going to fuzz all the contracts that are created. So that's going to work. If you cannot deploy everything within the constructor, it's a bit more tricky. We have Echidna. Let me find it. So it's actually here. So we have Echidna, which is a JSON RPC multiplexer, which can text, for example, your truffle test, initiate Echidna with your truffle test. So if you have like a really complex system where you need like a lot of initialization, like a call to a lot of initialization function between the different contracts, Echidna might be like the best way to move forward. It's a bit more complex to use, but yeah. If it's simple enough to fit within a constructor, go with a constructor. If it's more complex, you should go with a Echidna, and it's probably worth to join our Slack and which is here, and ask question to the Echidna developer. To be fair, it's not fully straightforward to set up testing for multi-contract. Good question, Platy. I don't think so. Let me think. So basically what Echidna is not an Echidna tool, but the way it can be integrated in Echidna is that it can replay the transaction that you sent to your chain, save the transaction, and give them to Echidna. But it's not going to give you the information that are already on chain easily. So theoretically, yes. At the moment, it's not possible. It's actually something we recently added to Manticore. Yeah, we could do it for Echidna, but we did not have the need so far. If it's something you need, feel free to open an issue in Echidna so that we can track it and see if we can make it working. And if you were able to run the example or finish the exercise 1, please go to the poll session just to give me some feedback on everyone's progress. Let's have 10 more minutes for this exercise. Sorry for the 5 more minutes. And don't forget to answer the poll in the session poll if you manage to run the example or to finish the part exercise. It's going to call all the public function from the contracts you can find. So you can also configure whitelist and blacklist. For example, if you have a large token, a large contract, and you only want Echidna to fuzz, let's say, 2 or 3 functions, you can configure it to do so. You will find this actually in the master branch. So you can either have a blacklist or a whitelist of function you want to call. And for the constructor, I missed with this question. For the constructor, it's just going to be the constructor of the token that you are giving it. When you run Echidna, you're going to specify a name of the contract if you have multiple contracts, and it's going to be the constructor of the contract which is provided here. It is going to be run. If you don't provide the -- contract flag, this is only going to work if you only have one contract. Otherwise, it's going to raise a warning saying it does not know which one it should run. So I'm going to upload the solution. Okay, so we have this contract. Let me zoom. Okay, so we have this contract we want to test. We know there is this transfer function, but there is no mint function. So we want to know if it's possible for someone to mint token. And the way we're going to do this is that we're going to inherit from the contract. We're going to create one user, which is going to be the default Echidna user. We're going to give 10,000 to this user. And the property that we're going to check is that the balance of this user should always be below or equal to 10,000, right? Because there is no minting function. And yeah, there's no way to create token. There should be no way to create token. So if we run this with Echidna, it's going to tell you that there is a way to break this invariant. So the invariant being that the user should have less than 10,000. And to do so, it's going to call this. So this is going to tell you that after the constructor, Echidna just called this function with this value, and it managed to break the property. So if you look back at the contract, it's here. You might have noticed that there is no check for underflow. So basically anyone can transfer any value. This is going to have an integer underflow, and the balance of the sender is going to be way like higher than it's supposed to be. So if you fix this and you run the same property, Echidna will tell you that it was not able to break the property. Show again the solution. Do you have any question regarding this exercise? Okay, let's go to the second one. Everything else. Exercise 2. Note protection made. So, Benjamin, have you run Solstice select? Let me find it. Have you run this just to be sure it's using the proper Solstice? So currently, Echidna, like we're trying to improve the error message from Echidna. Usually, when no transaction is made, it's just because it was not able to compile the contract or to deploy it. Now, if you run this command and run Echidna again, hopefully it should work. So, okay, which file are you trying to run? Like, can you copy and paste the command that you are running? Okay, maybe we can send me like a direct message, and we can manage this afterwards. Yeah, in the meantime, we have the second exercise. So it's the same, and zoom a bit. So it's the same code base. So you have this token with the same issue, but we're not going to check this. What you can notice in this contract is that it's a pausable contract, which means that you have pause and unpause function. the thing that we are going to try to test here is that if you're in a situation where you pause the token and you drop the ownership, no one should be able to unpause the token, right? Because only the owner is able to pause or resume the contract. So if you drop the ownership and you pause the contract, no one should be able to do the opposite. So it's what we're going to try to test with Echidna. So here we're going to have a specific deployment where we pause the contract, we drop the ownership, and we're going to create a property to check if anyone can resume the contract. And let's have 15 minutes for this one. And Benjamin, feel free to send me direct message if you want to exchange error message and stuff like that. Okay, so that's a good question, Flatty. So as I mentioned, the way Echidna works is that it's going to try random transaction to your contract. And it might break the invariant after 10, 20, or 15 transaction. If the report is like 10 transaction to break the invariant, while only one specific transaction did break the invariant, it's going to be difficult to read, right? So shrinking is a process of reducing this large sequence of transaction to a minimal one. So basically, like Echidna, once Echidna breaks the property, it's going to try to find the minimal example that breaks the property so that it's easier to understand what happened. So typically for this example, in one call, you can break the property, but in more like a more realistic example or more realistic scenario, you might need 2 or 3 call, and you definitely want to know which are the 2 or 3 calls that are needed to break the property to understand what the bug is. Because as we are going to see with this exercise, with exercise 2, sometimes you're going to write a property and you are going actually to find a bug which was not expected to be found with respect to this property. So it's going to make more sense with this exercise. So if you want to see more realistic example of Echidna, I'm sharing a blog post in the chat. So it was an example where we used Echidna to find a bug during the set protocol audit. It's a bit more complex than this example, but I think it can give you some insight on how powerful the tool is. All the tools that we're using today are tools that we're using during our say code review. So yeah, it's worth taking a look